In this video, we are going to talk about evaporation and crystallization. Both of them are used for extracting solute from a solution. For example, if we want to take out the common salt in a seawater sample, we can employ evaporation. And in this method, the filtered seawater sample are heated by these two setups. And during heating, the solvent would evaporate while the solute would remain as a solid and left on the evaporating dish. This is because it is much more difficult to evaporate the solute when compared with evaporating the solvent. And basically, there are two setups for evaporation. Can you tell the difference between them? The main difference between them is that the upper one does not have a steam bath, while the lower one have. So when using the upper setup, the rate of evaporation of the solvent is much faster, and we can obtain the salt in a much quicker rate. The benefit for using the lower one is that by using a steam bath, the heating is much more gently and would be safer when compared with direct heating. So if the solvent is flammable, which would catch fire easily, then we would choose to use the setup with steam bath. Then it comes to crystallization. Like evaporation, crystallization is also a method that used to separate a solute from a solution. Unlike evaporation, a saturated solution should be used in crystallization. And basically, there are two different methods for crystallization. The first one is to slowly cool down a hot saturated seawater. As we all know, the hot solvent can dissolve more solute when compared with the cold solvent. Therefore, if we cool down a hot saturated solution to room temperature, then the cold solvent cannot hold all the dissolved solute. And then the solute that exceeds the solubility of the cold solvent would crystallize out, and therefore it can be separated from the solution. Let's say the hot water can dissolve around 10 grams of sodium chloride, while the water in room temperature can only dissolve 4 grams. So there is 6 grams of the table salt that cannot be held by the cold solvent, and the 6 grams of the table salt would crystallize out. Simply speaking, this method employed is based on the difference between the solubility of a hot solvent and the solvent in room temperature. The solute that cannot hold it by the cold solvent will crystallize out. Then we come to the second type of crystallization. And this method is based on the decrease in volume of solvent. And in this method, the seawater sample is put under the room temperature, and the solvent would evaporate slowly. Therefore, as you can see from the diagram, the volume of the solvent keeps decreasing. And as the solvent evaporates, the solution would eventually become a saturated seawater sample. And as the evaporation of solvent goes on, the amount of solute that can be held by the solvent become less and less. The solute that exceeds the solubility of the solvent would crystallize out. Then we will talk about the difference between the three methods. Okay. Let's take a look on this table. In evaporation, the common salt that we obtain are in forms of powder. And usually they will have a lower impurity. Because in seawater, there are different types of salt. For example, sodium chloride, magnesium chloride, all of them will be included in the powdered product in evaporation. And for crystallization, the product that we obtain are crystal with high purities. It is because in seawater sample, the major component of the salt are sodium chloride. Therefore, when sodium chloride begins to crystallize, the other salts are still not saturated enough to carry out crystallization. So that the crystal that we obtain from this process are usually have high purities. And besides the difference in purities, the size of the crystal obtained from the two types of crystallization are quite different. The crystal that we obtain from the slowly evaporating the seawater sample at room temperature would be usually larger, while for the first method, by slowly cool down the hot saturated seawater would usually obtain a smaller crystal. The reason behind that is the crystal, in the second method, the crystal grows in a slower rate. Okay, it takes much longer time for the crystal to grow by slowly evaporating of the seawater sample. Therefore, the particle would have more time to arrange themselves so that they can pack in a much more regular position. Therefore, the crystal would be larger and have a higher qualities. And that's the end of this video. If you have any question, you can ask me through the Google Classroom. Bye bye.